Welcome to the deep dive. Today we're taking a really fascinating look into the latest in electric vehicle battery tech.
Yeah, there's a lot happening.
Definitely. We've been
Right.
looking at news, industry updates, trying to piece it all together.
Uh-huh.
And our goal really is just to give you a clear picture of these new developments, especially, what's going on with
Yeah,
BYD.
that affects everyone else.
Exactly. How it ripples through the whole auto world. We want to kind of cut through the noise, give you the insights that, well, that really matters.
Good plan.
And to kick us off, BYD has just announced something pretty big with their next-gen Blade battery.
Yeah, I saw that. Sounds significant.
It really could be a game changer. They're talking about incredibly fast charging, like maybe hitting 80% charge
Ooh.
in, well, super quick.
Like coffee break time quick.
Pretty much. Okay, so let's unpack this a bit.
Yeah, it's interesting, isn't it? If you look back just a few years ago where we were with EVs,
Oh, totally.
for a lot of folks, I think the idea was exciting, sure, but the practical stuff.
The hurdles.
Exactly. The charging times, how long the battery really lasts, the
Yeah.
cost, those are, real barriers.
Absolutely. You heard the same things over and over. Can I actually drive this far? Is the battery going to die in like 3 years? And that big one, is this just for rich people? And for a long time, the answer involved those lithium-ion batteries, right?
Right.
With nickel, cobalt, manganese,
Right. NMC chemistry mostly. And look, those materials, they gave us pretty decent range.
which was key, yeah, to get people on board.
Crucial. But as we've definitely seen, relying on those metals specifically brought its own problems.
Like what?
Well, they're expensive, for one. That push up the car prices. Then there were safety concerns, overheating risks,
The thermal runaway issue?
Exactly. And then you get into the whole supply chain side of things. Sourcing cobalt, for instance.
Yeah, you'd read about where some of that comes from, the conditions. It definitely gives you pause.
It does. So it kind of felt like the industry had hit a bit of a ceiling, maybe?
Yeah, it seemed like it. But then, what was it, around 2020? BYD came out with the original Blade battery.
Ah, yes. That felt like a real shift.
It did, didn't it?
It really did. The original Blade took a fundamentally different route. Instead of nickel and cobalt,
They went with LFP.
LFP, exactly. Lithium iron phosphate, which was, well, a pretty bold move away from what everyone else was doing.
And this wasn't just like swapping one ingredient for another, was it? It changed the whole picture.
Oh, completely. One of the big immediate pluses was safety. LFP is just inherently more stable, much less prone to overheating.
I remember those videos, the nail penetration test they did.
Uh-huh. Classic demo.
Sticking a nail through most batteries would be messy.
Extremely messy. Dramatic, let's say. But the Blade battery just sort of sat there. No fire, no explosion.
That kind of thing really sticks with you, doesn't it? A battery that doesn't, blow up is a strong selling point.
You'd think so, absolutely. Then look at the cost. By getting rid of the expensive nickel and cobalt, BYD suddenly had a way to make EVs potentially much more affordable.
Okay, so safer, cheaper.
And more durable, too. LFP batteries generally last longer. The original Blade was rated for a really high number of charge cycles, way more than many NMC batteries at the time.
So it's kind of no wonder it caught on so fast.
Not surprising at all, no. It really gained traction.
But BYD, clearly, they weren't just going to sit back. Now we've got this next generation, and the improvements sound, well, pretty impressive.
They really are. This new version basically takes the strengths of the original and just cranks them up. Energy density, for example.
Okay, what's the jump there?
They've gone from around 140 watt-hours per kilogram up to 190.
Wow, okay. That's, what, nearly 30%? Like 27% increase?
Yeah, about a 27% jump, which is substantial.
Okay, so translate that for me. For someone driving the car, what does that actually mean? More power.
The key thing is range. Higher energy density means you pack more energy into the same battery size and weight. So a car with this new battery could potentially go significantly further on one charge.
Without needing a bigger, heavier battery pack taking up space.
Exactly. It directly tackles that big one for potential buyers' range anxiety.
That makes perfect sense. More miles, same size battery.
Yeah.
That's a definite win. Okay, what about charging speed? That's always the other big comparison point, isn't it? Against filling up with gas.
Always. And this is where the new Blade battery seems to make another really big leap.
How big?
They're claiming 30% to 80% charge in just 30 minutes. Now, that's using a 110 kilowatt DC fast charger.
Okay, 30 minutes for that much charge.
Yep.
Still not 5 minutes, like at the pump, obviously.
No, not quite there yet, but it dramatically closes the gap, doesn't it?
It really does. It starts to feel less like you're, tied to the charger for hours.
Exactly. Less of an inconvenience, more manageable.
And I think I read something about it running cooler during charging, too.
That's right. Better cooling means less energy is wasted as heat, so the charging itself is more efficient.
And presumably better for the battery long term. Less heat stress.
Precisely. It can definitely contribute to a longer lifespan for the battery pack. It all points towards a more refined, more efficient system overall.
So how did BYD actually pull this off? These are pretty big gains. Was it like one sudden magic discovery?
Doesn't sound like it.
Yeah.
The sources really emphasize that it's more about consistent, step-by-step work, relentless refinement,
Okay.
building on what they already had, making incremental improvements, careful engineering, better material science.
So it's still LFP chemistry at its core, but they've likely tweaked things, I don't know, inside the battery.
That seems to be the idea. While sticking with LFP, they've probably innovated in how the cells are structured, maybe how they're packed together, cell-to-pack efficiency.
Right.
And using more advanced materials, maybe in the electrodes or the electrolyte, to just optimize how the energy flows in and out.
Like optimizing the layout inside a computer to make it faster, even with the same basic processor type.
That's a pretty good analogy, yeah. Getting more out of the same fundamental chemistry.
And it sounds like BYD having so much control over their own manufacturing is a huge factor here.
Oh, absolutely. That seems critical. Unlike a lot of automakers who buy batteries from, LG Chem or Panasonic or CATL,
BYD makes their own
that's
stuff.
a very high degree of vertical integration. Yeah, they handle so much in-house. Design, materials, production, assembly.
And the benefit there is?
More control over costs, definitely.
Yeah.
Streamlined production. And crucially, they can implement new ideas much faster. They're not waiting on third-party suppliers to catch up or change things.
So they can just iterate faster.
Yeah.
Test, improve, repeat. Much quicker cycle.
Exactly. And that improved heat management we talked about,
Yeah.
that's likely tied into their materials and pack design, too, if the components naturally generate less heat.
You don't need such a complex, heavy cooling system.
Right. Which saves energy, saves weight, improves reliability. It all connects.
Okay, so this sounds like, well, a really big deal for BYD. But what does it mean for everyone else? For the rest of the EV industry? Feels like this could really shake things up.
That's exactly the potential, isn't it? These advancements from BYD, they're a direct challenge to companies like, Tesla, GM, VW.
The established giants.
Right, who have, invested billions in nickel and cobalt-based batteries to different extents.
And those chemistries, while good on range, still have those issues we mentioned.
Exactly. Higher costs, those potential safety concerns, the complicated, sometimes ethically fraught supply chains.
So BYD is coming in strong with a tech that seems to sidestep some of those big headaches.
That's the crux of it. Cost is huge. If BYD can make EVs with similar or even better specs, but sell them for less,
Because their batteries are cheaper to make and they're efficient.
it puts immense pressure on competitors.
Yeah.
They either have to innovate just as fast, find ways to cut their own costs, or risk losing market share on price.
And that safety angle, too. The Blade battery already had a good reputation there.
Absolutely. Building on that fireproof image, this next generation could ease even more consumer worries about, thermal runaway risks.
Which might still be holding some people back.
Could be. And then, that faster charging time, it just knocks down another barrier to adoption for a lot of everyday drivers.
It's interesting, too, that even Tesla seems to be hedging its bets a bit. Didn't they start using LFP in some models?
Yes, exactly. That's a really significant sign. The market leader sees the benefits of LFP, especially for their standard range, more affordable cars.
Right.
But the sources do point out Tesla still relies heavily on external suppliers for battery,
Whereas BYD have that in-house control.
which gives them that unique agility, that control over the whole process.
Which could make it tougher, then, for companies like VW or GM who've built massive factories around nickel-cobalt tech.
It could be a real challenge, yeah. Pivoting is hard. Overhauling supply chains, retooling factories for LFP on a huge scale.
Yeah.
That takes serious time and investment.
While BYD is potentially just accelerating away.
They might find themselves playing catch-up if BYD keeps this pace. Yes.
Makes you wonder if governments might step in somehow, like setting new benchmarks or pushing for this kind of safer, cheaper tech.
That's definitely a possibility, as governments push harder for EV adoption globally.
Right.
BYD's tech could almost become a new standard to aim for. It might influence regulations, maybe incentivize similar moves in safety and cost across the board.
Okay, so BYD batteries, huge deal. But it sounds like their ambitions don't stop there.
Oh, I saw something about flying cars. Seriously.
Right, it sounds like sci-fi, but yeah. What's really grabbing headlines is this flying car they unveiled
Okay.
and the target price point, around $5,000.
5,000? That can't be right. That sounds impossible. Flying cars are usually like luxury toys for millionaires.
That's exactly what makes this so different. Most other concepts are way up there, hundreds of thousands.
Uh-huh.
BYD seems to be aiming for, well, mass adoption right from the start, seeing it as a practical fix for, say, city traffic. And how could they possibly aim for that price? Is it linked back to the EV stuff?
Absolutely. It seems their deep experience in batteries, their control over manufacturing and supply chains.
Their knack for cost-cutting in EVs.
Exactly. All of that is apparently the foundation. The scale they operate at in EVs probably gives them huge leverage to try something like this at a potentially disruptive price.
Okay, so what is this thing? What are the specs? Is it like a drone you sit in?
Sort of, maybe. It's described as electric, obviously. Compact, about 12 feet long, 5 feet wide. Weighs around 1,500 pounds.
Okay.
It's got retractable landing gear, apparently a simple cockpit design. And importantly, it's designed for short takeoff and landing. STOL.
Meaning it doesn't need a massive runway, maybe just a clear space?
Potentially, yeah. Like a large parking lot, maybe. Top speed is supposedly around 80 miles per hour.
And the range? Can't be huge on a small battery.
No, reported range is about 25 to 30 miles per charge. And they say it has safety features like automatic stabilization, emergency landing systems.
Okay, so definitely short hops, urban mobility, like you said, zipping across a congested city, maybe.
That seems to be the idea.
Still, even for short hops at $5,000, that could be massively disruptive, couldn't it? Compared to other flying car concepts.
Huge disruption potential. It challenges everyone else working on those super expensive, complex designs. And speaking of disruption and scale, there was another really significant point in the sources. BYD's overall revenue has now actually eclipsed Tesla's.
Wow. Okay, that is a headline. That really signals a major shift happening in the whole EV landscape, doesn't it?
It absolutely does. It underlines their massive growth and influence globally.
So we're seeing these huge jumps in battery tech, now this wild flying car ambition. It really feels like the whole EV and personal transport space is just accelerating incredibly fast.
It really is. If you zoom out and look at the bigger picture, EVs have clearly gone from being this, niche curiosity.
For early adopters and tech fans.
Right, to a genuine mainstream global trend. And it's driven by this powerful mix of things.
Like what?
Continuous tech innovation, obviously. Costs coming down, making them more accessible. And I think a growing focus on designing EVs that people actually want to live with day to day.
And it's not just the battery anymore, is it? These cars are becoming like rolling computers.
Exactly, packed with digital tech, smart features, over-the-air updates that actually improve the car after you buy it.
Right, adding features or improving performance.
Sophisticated driver assistance systems becoming more standard. All that digital stuff is advancing right alongside the battery breakthroughs, the better range, faster charging, lower costs.
And you mentioned manufacturing earlier. How they're actually built seems super important too.
Absolutely crucial. Companies that figure out innovative manufacturing, more automation, that vertical integration like BYD and Tesla.
They gain a real edge.
They do. They can accelerate progress, get costs down. Modern EVs are really becoming these connected hubs, aren't they? Offering personalized experiences and hopefully reducing our environmental footprint.
Which is a big driver for many people switching, right? The green aspect.
Definitely. Zero tailpipe emissions is huge.
Plus the lower running costs, potentially less maintenance.
Quieter drive, often quicker acceleration.
And government incentives in many places help too.
Absolutely. All those things are broadening the appeal way beyond just the eco-conscious buyers.
And the source mentioned Tesla's aiming for a new, much cheaper car. Around $7,000.
Yeah, that was mentioned as another sign of this push towards accessibility, a potential breakthrough in affordability, hopefully without sacrificing too much on the tech or design people expect from Tesla.
Right. It shows this drive to bring EVs to the masses. And it's interesting to see the different ways companies are tackling that. You've got Tesla's approach.
Which tends to be more minimalist, tech-focused.
And you have those ultra-budget Chinese EVs like the Wuling Mini.
Tiny, basic, super cheap.
And BYD's own Seagull EV, the Honor Edition, which someone apparently nicknamed the Mini Lamborghini.
Yeah, a bit more style and features, but still aiming for that affordable end of the market. It shows there are different strategies at play.
It really paints a picture of innovation driving change across the board. Economics, the environment.
Even geopolitics, yeah. Government policies are pushing hard, setting stricter emission rules, offering EV tax credits.
Which forces companies to invest and innovate.
Exactly. And think about where battery factories are built that becomes strategic. Reduces logistics costs, supports local economies, meets environmental goals.
And linking EVs to renewable energy sources for charging.
That's key for the whole sustainability argument, isn't it? Making sure the electricity is clean, too.
And we keep circling back to it, but the battery tech is just fundamental to all of this.
It really is. It's the heart of the EV. Dictates range, performance, cost, safety, everything.
And the progress from companies like Tesla on the manufacturing side, BYD with this blade battery tech, it's setting new benchmarks.
Absolutely. For energy storage, for safety, for cost efficiency.
And that vertical integration strategy we talked about, Tesla and BYD, both doing a lot in-house.
It seems to be a winning strategy, doesn't it? More control, more resilience in their supply chains, faster adaptation.
As EVs become more mainstream, what people expect is changing too, right? It's not just about being green anymore.
No, definitely not. Cost of ownership becomes critical. Reliability, charging convenience. How easy is it really to live with one day-to-day? The infrastructure needs to keep up.
And the role of data and connectivity seems huge too.
Oh, massive. These cars generate tons of data. It's used for optimizing performance, for those over-the-air updates, for driver assist systems.
Predictive maintenance, maybe. Telling you something needs fixing before it breaks.
Exactly. And offering more personalized settings and experiences. Plus, looking ahead, integrating vehicles with smart city infrastructure, traffic flow management, parking.
The potential there seems enormous.
Yeah.
But underlying all this tech excitement, we can't lose sight of the original why, can we? The environmental motivation.
Absolutely not. Fundamentally, this whole shift is driven by the need to, well, reduce our impact, cut pollution, conserve resources, tackle climate change.
For future generations, yeah.
But it's also important to have a balanced view, right? EVs eliminate tailpipe emissions, which is great for city air quality.
What?
But we have to look at the whole life cycle. Where do the battery materials come from? How much energy is used to build the car? Where does the electricity for charging come from? What happens to the batteries at the end of their life?
Right, the hidden environmental costs. It's not zero impact.
No, nothing is. A truly sustainable approach needs to consider all of it. Mining, manufacturing, energy sources, recycling.
And it sounds like the major players are starting to focus more on that. Tesla's work on battery efficiency, recycling initiatives.
Using more renewable energy in their factories and charging network. Yeah, there's definitely a growing awareness that you need a comprehensive strategy for true sustainability.
So looking ahead, what's next? More battery breakthroughs?
Seems likely. Continued advances in battery chemistry are almost a given. Maybe solid-state batteries eventually. Further digital integration, making the car even smarter. And, crucially, building out and improving the charging networks.
To make owning an EV seamless for everyone.
Exactly. Paving the way for EVs to become, well, the default choice. The dominant way we get around.
It really feels like more than just a tech shift. It's like a fundamental transformation.
It is. It impacts economics, how our cities are designed, our daily lifestyles. It's a massive movement, really. And the direction it takes depends on choices made by, well, us as consumers, by policymakers, and by these industry leaders pushing the boundaries.
Okay, so to wrap this up for everyone listening, let's try and boil down the key takeaways from this deep dive.
Sure. I think the main point is that BYD's next-gen Blade battery looks like a really significant leap. It tackles those core EV challenges, charging speed, safety, cost, head-on.
And that puts serious pressure on the established players.
Definitely. It's a major competitive challenge. And then there's their flying car ambition.
Which sounds wild, but shows how broad their vision is, redefining transportation, basically.
Exactly. And zooming out, the whole EV scene is just evolving incredibly fast. Innovation in batteries and manufacturing, digital features, all pushing towards making EVs more sustainable and, crucially, more accessible.
And hopefully this discussion has given you some valuable insights into all these really important developments happening right now.
Hope so.
Finally, just a thought to leave you with. Seeing how quickly things are moving in the EV world, what other transport tech that seems like pure sci-fi today might actually become commonplace way sooner than we think.
Interesting question.
Something to chew on. Thanks for joining us for this deep dive.